Good day, everyone. It is nice over here for you and I because learning never ends and education is the key to an impactful life. My name is Anthony Nathaniel.
Good day everyone, and welcome you back to our physics course for secondary school. In this episode, we are going to be dealing with um, fluids at rest and fluids in motion. Now, last episode we talked about crystal structure, but this episode we are dealing with these fluids, and we are going to be dealing with surface tension, capillarity, and other things. The first concept we'll be dealing with today is surface tension. And surface tension, it is an everyday observation. For example, when you have a tap or faucet and you have some drops of water in the hole coming down. Now, the surface of the liquid behaves as if it were a stretched screen. And of this same liquid, you can see that it is suspended like as if there's a bag of nylon or leather that's holding the water. But nothing is holding the water, it is just the surface tension. Now, when the water will appear to fill a balloon or an elastic skin. Now, the elastic bag supports the weight of the water. So that is why this water can stand. From that observation, we can safely conclude that surface tension is the force acting along the surface of a liquid, causing the liquid surface to behave like an elastic or stretched skin. Now, there is a molecular explanation for surface tension, and that is explained by the fact that um, there are forces of attraction between the molecules of the liquid. When you consider a liquid in a vessel, on the average, the molecules in the liquid are attracted by other molecules in all directions. But when you have a molecule that is um, basically close to the surface, it's the there are no other molecules attracting it from the top. So because it's at the top, so that means there's an imbalance of forces. That means when you arrange those molecules together, so as you can see in this diagram, you have the molecules at the interior of the liquid, molecule M. So all the forces of attraction and whatever, all the forces are balanced around it. But the molecule N on the surface, you can see that there are forces from the side and below, but there are no forces above it, above the surface. So that means it has many molecules pulling it from below, but none pulling it upward. Such molecules will experience a resultant force acting downwards at right angle to the surface because all molecules on the surface of the liquid experience this resultant downward pull, and the liquid surface will always tend to shrink, thus making the surface area as small as possible. So the surface is therefore in a state of strain or tension, which we call surface tension. Now, stemming from our knowledge of surface tension, let's move on to another phenomenon. So if we dip 3 tubes of fine balls with different diameters into clean water, we observe that the water rises in the tubes, but the narrower the ball, the higher the height to which the water rises. So you can see in this diagram that the narrow tube holds more height of water, while the wider tube with the greater diameter holds less volume or height of water. Now, the phenomenon described earlier, which is the tendency of liquids and fluids to rise and fall in tubes, is called capillarity. Now, this rising and falling, it's associated with the surface of meniscus. So the surface of that column is called the meniscus, and in water the meniscus is curved upward, whereas in mercury the meniscus is curved downwards away from the glass tube. So now let's talk about cohesion and adhesion, which will be required to explain capillary action. And then cohesion is the force of attraction that exists between molecules when they are of the same kind, like between water molecule and another water molecule. It's called the force of attraction cohesion. Whereas adhesion is the force of attraction between molecules that are not of the same kind, like between water and glass. So you know that there's an addition. So this is a diagram to explain cohesion and addition. Now, in the case of um, when we spill different substances like water and mercury on glasses or glass surfaces, you can see the meniscus, that is the angle of contact, how they look like. Now you can see that the one of water has kind of like a smaller angle, while for mercury it's kind of like a wider angle. Now this water wets glass rather. So the addition of water molecules to glass is so strong so that the water wets glass. But the cohesion between water and water molecules is not as great as the addition between water and glass. But in the case of mercury, you have the opposite way around. The addition between water, mercury, and glass is not strong, but the attraction between mercury and molecules is stronger. So that's why mercury doesn't wet glass. And when you drop mercury on the surface, it gives you these balls, these kind of like separate balls. But when you drop water, they kind of wet the glass and spread around. Some episodes ago, we were talking about friction in solids. Now, when we talk about friction in liquids, it is analogous to viscosity, which is the internal friction between layers of a liquid or gas in motion. So you need to understand that for viscosity to hold, there must be relative motion between that liquid and gas. So that is not difficult because liquids and gases, they are always in motion. They are particles. They are not like solids, which are restricted to vibrate around mean positions. Now, so that's why viscosity is a kind of very easily understandable topic in terms of fluids like liquids and gas. Now, this is a diagram to help us understand viscosity. And when a stone falls through a viscous liquid, it's subjected to three forces. So as you can see in this diagram, it's subjected to two upward forces, which are the upthrust U and the viscosity V of the liquid. Now then there's a downward force, which is its weight. So you know that weight always acts downward. Why? Because gravity is a force of attraction towards the earth. Now the viscous force acts upwards. So and it opposes the motion of the stone, also the upthrust. Now these forces, we'll talk about how to balance them and what they result in later on. But then there's what is known as terminal velocity, and which is the velocity that the object attains when these forces are balanced. So and then when these forces are balanced, an acceleration of zero. So that velocity at which the acceleration of zero is called the terminal velocity. This is the equation that expresses the balances of the forces, and then our equation becomes W, which is the weight, minus V minus U equals ME. So that is when the object is still accelerating. Then when we rearrange, we have viscosity is equal to the weight minus the upthrust. So this constant velocity is called the terminal velocity. So when the acceleration is zero. Now at the start of this video, I talked about a similarity between viscosity and friction, and the similarity between those both is that they both oppose relative motion, and also they both depend on the nature of the materials in contact. Now, but the difference is that friction does not depend on area of contact, whereas viscosity depends on area of surfaces. Also, friction is dependent on normal reaction, which viscosity is not. Also, friction occurs in solids, while viscosity occurs in fluids or liquid and gases. Then finally, we have that friction does not depend on relative velocity between two layers, whereas viscosity depends on the relative velocity between two layers of the surfaces in contact. So this is as far as I can go in this video. I hope you enjoyed this video. Now you can also try the questions which are related to this topic, and then you can send your answers to the number in the description of this video at WhatsApp. Yeah, we've come to the end of this video, and these are questions that you can decide to try. So if any ones you are able to solve, you can also send the answers, or as you can comment as the answer, you can send it to the number in the description of this video. Thank you for watching this far, and see you next episode. There we'll be talking about solar energy and harvesting of solar energy.